Hello, welcome to Unit 5, Lesson 6, even more graphs of functions. What we're really looking at today is the qualitative results of functions, meaning that we're looking at how to really read a function and to understand how the function works. In this function, you have pictures of 5 pictures of a dog that are taken at equal intervals of time. And now it was really hard to see this, so I made a special highlighted dog. I think it's a little radioactive. But Diego and Lynn both drew these from different representations, and here's what they drew. So Diego's graph started out here with a little flat line towards the beginning, and then it climbed up, and then Lynn's started out a little bit further and came down. And they both used time as the independent variable. So what do you think each other used for the dependent variable? And I think one of the things to recognize with graphs is it's all based on perspective from when you get to situations like this. So when we talk about this, if this down here is representing time for both graphs, then it's reasonable to assume that the y-axis is distance for both graphs. And what that does for us is understanding distance. It means that there's two different things happening. Either for Diego and Lynn must be sitting in a different place. So with this one, Diego must be sitting back here by the dog, because what we see is that the dog is just sitting still for a couple moments, and then the dog gets up and starts to lead away. The distance starts to increase away from Diego. Whereas with Lynn must be sitting over here, probably closer to where the dog would be, more like here in the foreground. And so the dog is sitting quite a distance away, but over time that dog becomes closer and closer and closer. And so it would have to be, it would have to be something about a distance with that piece. So what we're looking at with this in just a brief moment is that we're going to look at naming independent and dependent variables, and we're going to pick graphs that best fit situations or sketch the graph if it isn't provided. And so with this first one, or as we do these, we're going to label axes. We're going to answer a question: which qualify as a function, or is a function of which, and be prepared to explain. So Jada is training for a swimming race. The more she practices, the less time it takes for her to swim one lap. As we look at this, we should be able to look at these pieces and recognize a couple of things. What can we conclude about a swimming race? As she practices, she should be able to take off more time. She should be able to get faster. And so when we look at these, with this one, this would be a representation of her starting time. And then as we're looking at this piece, as she goes along, her time decreases. And so this would have to be lap time, because that lap time can be measured over amount of time. That lap time is something that is a function of more and more and more practice. So we would recognize that all of these have to be practice time. So if we think about it, which one represents the practice time? As more practice time is happening, we have less lap time. And obviously it'd have to be this very first one right here, because what we see is as the practice time increases, the lap time is decreasing. Whereas this one, we would see that as the practice time increases, the lap time is also increasing, which we don't want that, because that would mean that she's getting slower. And on this one right here, her practice time does a dramatic thing. As the practice time increases, her lap time actually increases, but then kind of plateaus. So it wouldn't make sense right here. This does not indicate that she's getting faster. This one definitely does indicate that she's getting fastest. Andre adds some money to a jar in his room for each week for 3 weeks, and then takes some out in week 4. So we don't have anything in here to assume that he has money in his jar. So we would say that we're talking somewhere right here. We don't know if there's a constant rate or not, but we could kind of look at that. It says that he adds some money to a jar in his room each week for 3 weeks. So if we're talking 1, 2, 3, 5, 6, 7, we'll need 7 of those. So if he's adding some money to a jar for 3 weeks, perhaps we can just pick any point out here as long as it starts coming up here at 3 weeks. And then he takes out some money for another 4 weeks. Or takes some out in 4 weeks. Sorry, there's a very key word there, in 4 weeks. So we have Um, with that 4 weeks, we can interpret right here in 4 weeks right here, or we can consider that another 4 weeks right here. So his balance inside that piggy bank stays there, and then it starts to decrease. So what we'd have to look at with this is we would have to look at something like number of weeks, and then we would have to look at money that's actually in the jar. So that's really what we're looking at with these and trying to figure out how different pieces add in and how different pieces add up. The next one, you actually get the opportunity to kind of play around with it. It's sketching a story about a boy and a bike. The interactive link will be given in your description for today's work. It says that I'll give you tools for creating a visual display, and that's what that link is. And here's the story. Noah was at home. He got on his bike and rode to his friend's house and stayed there for a while. Then he rode home again. Then he rode to the park. Then he rode home again. So we would create a set of axes and sketch a graph of the story. What are the two quantities? Label the axes with their names and units of measure. For example, if this were a boy about pouring water into a pitcher, one of your labels might say volume in liters. This is clearly about Noah riding his bike and where he's going from place to place. And so on a piece of paper, it could look something like this. And what we'd have to recognize with this is that this is going to be a function of distance over time. And this can be represented a couple different ways. So when we talk about this, Noah was at home. So home, let's put home at 0, 0. He got on his bike and rode to a friend's house and stayed there for a while. So he went through some kind of distance, and then he stayed for a little while, and then he rode home again. And so home again would have to be back on the x-axis because there's no distance away from home. And then he rode to the park. And who knows, maybe the park's right here. And then he rode home again. But you notice the difference between the two. This one tells us that he stayed for a while, and that's why we see a little bit of plateau right here. But going to the park, we don't see any time that he says that he stayed, and so this could be that one example. So now as we look, there's a few different ways that this could actually be represented. When we look at these pieces, his distance from home, here's one that's like this. It's a little bit different than mine, but his distance from home in miles, we see that he actually started at home, went to his buddy's house. Let's see if I can get some color on there, some blue pen. I don't know if it'll show up, but we'll see. So he went up to his buddy's house, stayed for a while, rode home. And then this graph, it says that he actually stayed at the park for a little while, then rode home. And then maybe distance from the park is the way you wanted to say from this. And so he rode away from the park to his house or towards his house, and he's riding around, getting closer to home, and then goes back, stays somewhere for a while, then finally gets home. And then this one, the distance from the park, he rides away from the park and stays away from the park. Total distance travel would be something like this, that he rode to his buddy's house, stayed for a while, rode home, a lot more distance, stayed at home for a minute, rode to the park, stayed for a little bit, and then rode some more to come back home. There's a lot of different ways to interpret these pieces. Reading the stories, it's based on how we draw it that's really going to give us the interpretation of the graph. And so recognizing that the way that we label our axes and the way that we tell the story really determines how the graph is going to be made, whether it was him riding from his house, making that be the starting point, or the distance from his house compared to the distance from the park, compared to the overall distance that we're talking about. So what we can think about with this, here's a graph showing Andy's distance as a function of time. When we're talking about a distance as a function of time, meaning the distance relies on the time, we have the context that can be given or assigned to this. It's important to specify the quantities represented for each axis. So for example, in this one, if this is showing distance from home, then Andy starts at some distance from home, meaning he started somewhere. Maybe this is his buddy's house because he's clearly not at home. And then he rides some distance away, maybe goes to a park or maybe goes to a grocery store or somewhere else. And he stays there. And we know that he stays there because it's just a flat line. There's no more distance that's changing. He's getting no closer, no farther away. And then finally at the very end, it shows that and he starts out, or that he's coming home, moving further away from his friend's house, whatever it may be, back to home. So there's a lot of ways that we can do this. There's possibility talking about the graph showing a distance from school, and the story may be that Andre starts out at home and he moves further away, maybe to a friend's house, and then he goes to school. Or what could the story be if the graph is showing distance from a park? If it's distance from a park, then we're talking about his distance. He increases his distance, stops for a little while, and then continues his distance. Like I said, the story has to be very specific to match the information, but hopefully you get the idea that a function can be something that's written for any situation. We just have to understand that giving it and assigning it the correct dependent and independent variables is critical to assigning a good outcome with it. So thanks for stopping in. Let me know how I can help.